Welcome to the second plenary session of the Mining Goes Digital conference. The mining and metals industry in Kazakhstan plays a significant role in the country's economy, accounting for 17.5% of GDP and generating around $10.5 billion USD in exports. As of 2021, the industry employs more than 273,000 people, making it an important source of employment. However, the sector faces challenges due to outdated technology and management practices, which can be traced back to Soviet times. Digital transformation in the mining and metals industry of Kazakhstan can help address these challenges and optimize its functioning. To capitalize on the opportunities presented by the digital economy, the mining and metals industry in Kazakhstan needs to undergo a digital transformation. A key aspect of this transformation is the development and implementation of new digital platforms and business models that optimize the functioning of the industry and the allocation of resources. This can be achieved through various strategies, such as the exploration of mineral resources, automation and digitalization, infrastructure development, and investment in staffing and enhanced environmental management. By embracing digital technologies and innovative business models, the industry can enhance its global competitiveness and contribute to the overall growth of the Kazakh economy. Join our panel of experts and industry leaders to hear about the latest cases of automation and digitalization of mining assets management, from pilots to production chains and digital twins.
Меня зовут Константин Давкаев.
Good morning, I'm Konstantin Davkaev. I will be the moderator of this session. A couple words about the topic of our presentations. All of us understand that digitalization in mining sector is a key driver for improvement of the efficiency of the mining businesses. This session will contain several presentations, and we will discuss the opportunities provided by our colleagues to resolve this task. A couple words about the questionnaire. What defines a decisive factor for stimulation development of digital transformation of mining industry in Kazakhstan? Tax-intensive and successful implementations. These are the most popular responses to the vote, and I would like to say that actually the decisive factor for stimulation is a competitive environment, as we have to understand that the better staff is trained, they should better understand that digital transformation is a decisive factor in the development of a mining sector in the current conditions. So let us start the presentation. The first presentation will have two speakers: Sergey Tsvetkov, Commercial Director, Clickman Kazakhstan, and Nurjan Siskinbayev, Business and Technology Services, will speak about establishment of a system for corporate storage of technical data in ERG Group. Thank you for presentation, for introduction. And I would like to introduce ourselves once more. I'm Sergey Tsvetkov. I'm from Klinkman Group of Companies, and we're in Kazakhstan, a distributor of Aviva Corporation on software products for automation of industry, for digitalization. And you may see at the diagram that contains a key scope of products. And today we will be discussing the implementation of a corporate storage of technological data, SCADA data, implemented at the portfolio Aviva. That is the basic or the key elements, everything which is related to the processing of information and data processing. With it, I'll provide the floor to my colleague Nurjan without stealing his time. Good morning to everyone. Today I would like to describe the project of corporate storage of data implemented at the group companies. This product was initiated at our Almaty Digital Forum, where our head was talking about the proposal to create a Eurasian Economic Community data storage, so as a company in the Eurasian Economic Union could store the data and share the experience of technological processes management. So now, after this proposal, the objective of creation of this uniform point of collection of storage and accumulation of the data of SCADA, and another objective is a uniform approach to connection to SCADA machines of the group companies and simplification of retrieving data from SCADA through artificial intelligence. This project was initiated in 2021. Coordination of architecture and procurement took us more than 5 months for implementation. We spent a year and a half. And for now, in February, we are completing the project and we are closing it on the 5th of May. But what did we have in the beginning? We have scattered and the data and the task to finish the project by the end of 2022. And we had 8 companies in the Eurasian group having SCADA system. All these are scattered system disconnected that have to be connected based on united methodology of tech creation, where we use uniform mask in Eurasian group of companies, and we prescribed uniform requirements on connection to SCADA system. We discussed 6 suppliers at the bidding process, and Klinkman Kazakhstan won this competition. The architecture in Eurasian group, we applied at every local company, local virtual machines in the format when one machine is responsible for local history and 2 machines which are responsible for home driving, for reserving and data transmission. The companies, SCADA, almost Emerson, Schneider, Siemens, 3, but in the head office we established also a virtual machine for 200,000 tags. It's a Viva historian also. The clients are the system of operational control math systems which are being developed nowadays at the companies of the Eurasian group, and digital advisories. And also we managed to create a situation when technical services of the company are capable and are needing to offload this data to check a particular hypothesis related to technological process management. As for the benefits of the project, we have organized central point of data collection. Our historian is great in the sense that it produces requests for data and their retrieval. And also we can address to the data based on the requests, and we can establish mechanisms of maximum, minimum, or averaging the data. And also the discrepancy of the data is also considered as a result of the project. We have completed the project already in late February, and now we are finalizing it, and we have transmitted the system to launch the system to operation. I would like to mention about advantages and difficulties of working with a web historian. As for advantages is a value and price and value ratio according to the tasks that we have been set. It's convenient and easy to use by administrators and final users. It simplifies the training of final users for data use. And it is easy to deploy the system in accordance with the architecture. We have some difficulties. We do not have automated monitoring of the conditions of connection with SCADA systems, If some part of the system is not able to provide data to local historians through ComDrive, unfortunately, we do not find the mechanism, but now we are trying to establish this mechanism, how we can track all these failures. Another issue is impossibility to identify time tag and incorrect adjustment of time tag during historian service instead of the time of a source. So how we can extend, if we get to historian and if we have to look and offload the data for a particular period, then it appears that if we make a request on from 10 o'clock and in the first time,
then sometimes we can have data, but the time tag is lost for this data. We submitted the request to the technical support group, and we are expecting the answer from them, and I hope that the solution will be found. That's it for my presentation. If colleagues, you have some questions. Nurjan, thank you. Any questions? Any questions to the speaker? Because we still have a couple of minutes talking about the digital advisors. Let me repeat my question. Dmitry Schneider from Belka AI. You mentioned that you introduced the digital advisors. Where you implemented them, and what is the result of that? Talking about all the advisors that ERG is having, I cannot answer, but within my competence, Aluminium Kazakhstan division and the Kazakhstani electrolyte plant, I can answer that there is a digital advisor on virtual sensor and for clearing and other estimations of the load. That was done for the Kazakhstan, because the other enterprises, there are advisors, but they are not matched to the project because of its specificity. But if there is a request, we can fulfill it. We can entertain it. Thank you, Nurjan. One more question? Yes. Thank you for the presentation. Very interesting topic. I don't get what is the meaning of the collection of data. You collected the data, okay, and you mentioned that there is an opportunity to take this data and analyze them. It means that it's kind of an so it's not planned actually, but whether you're going to use this data systematic, these are the projects that are working now and will be working in future. For example, now we are implementing the project MES system in ERG. Then there they need actual data, real-time data all the time, and the corporate data storage can help with that. Why we implemented that actually? Earlier, just for your understanding, in ERG there are 8 enterprises with different automation level and different with different operations. So these are Aluminium Kazakhstan, there's mining companies, and so on and so forth. The automation level is different in all these enterprises, but we connected to them. We collected all the tags in one database, and the request from any system the enterprises are using, so they are using is just one function, or the data can be submitted from database to database. Okay, Nurjan, thank you. Your time is up, but you can discuss it after the conference during the break. So in more details. Now I'm giving the floor to the next speaker. Our next speaker is Tairjan Salikov. He is the head of production and technical department, Polymetal Eurasia. He will be talking about optimization of flotation cycle management at the Bakarchik mining enterprise using AI on the Brains APP platform. Hello, dear participants of MINEX forum. I would like to present you the following project. At present, this project is being implemented at one of our companies in Abay region. It's Bakarchik mining company. The essence of the project is to use production AI using platform Brains app. Just for introduction, I would like to tell you there was a high level of automation system at the enterprise to manage the technological process. To collect the input data, we were actively using RockSense, MillSense, granulometer, PCI 300, and so flow analyzer courier, and FrostSense and MillSense. Also, in the company, at the enterprise, we're using other different systems for information collection about the capacity, the features of the ore and the processes. For example, the system of geological technical mapping, where we are collecting all the data about the work of the equipment and other pieces and other systems to collect the information on different purposes. The goal of the project was to ensure the stable flotation process for the ores, to use to achieve the concentrates with the specific qualities and specific levels. And we are using AI, so we are going to resolve such tasks. First of all, we would like to increase the extraction during the flotation. We would like to manage the process, technical process properly. So optimize the usage of reagents depending on the components of the ores and so on and so forth. On the slide, you can see the current chart of the technological process. This is the tech flow, tech chart. So grinding of the ore concentration and the drying of the concentrates. For any enrichment plant, what they need is to timely manage their process and to optimally use very costly reagents and to manage the flotation process properly. How we can do that? We can use virtual sensors, but also additionally we are developing application to optimize flotation. This application is based on the characteristics of the ore, and it helps to focus the processes in advance, 1 hour in advance, and these apps can provide recommendations on the optimal usage of the equipment. For example, the air, the foam, and so on and so forth. If we implement these solutions, then you have the real-time picture of the kinetic properties of the flotation process by cells, and it helps to implement these tasks in the project. This is the current status. So how to control the technological process? It's a visual control of the flotation. So the color of the foam, the bubbles, the size of the bubbles, the testing of the samples in the labs, and then the decisions are made based on the experience of the operators of the plant, technologists, current operational data about the quality of the product. When we implement AI, then we enrich all the information. We can focus the process one step in advance, and then we can adjust this process and manage this process using AI of the application. The recommendations for the management of the process, we are getting these recommendations from AI, but the decision is still made by, the final decision is made by the operator during the pilot stage. But then later we consider that we can completely automate the management of the process using AI. On the slide, you can see, just a second. Okay, implementation. The partner develops different models of the enrichment process, and using all the measurements, operational data, AI is focused in the KPI of the process in real-time mode, and then AI gives the recommendations for optimal process and modes, and gives recommendations, for example, for area management and other things of the process. The current status of the implementation. Actually, the project is comprised of two stages. During the first stage, we installed the platform and initially launched the software in order to collect the data and conditions of the process itself. And we identified the necessary data for that we need to receive from the virtual sensors. We analyzed anomaly data and others, and then we conducted the mathematical analysis, and we identified the quality and quantity characteristics of the ore. This first stage is over now. The tasks of the first stage have been implemented. We identified the list of the information system needed to collect the data for the application and the AI. We are at the final stage of the second stage. This is the chart before, let's say. Here we are talking about manual measurements, lab test results, and the decisions are made manually by person, by the operator, based on the experience. And then the operator introduces certain changes to the system, what needs to be changed in the process. On this slide, this is the decision-making logic is described, how we, based on what we are changing the processes. The virtual data is taken into account, mathematical assessment is taken into account, and then the decision to change the process or the recommendation to change the process is made by AA, and this recommendation is given to the operator. We tested the AI during the second stage, and we can make the conclusion that this prototype of the model, how to manage the technical process using AI, is developed. The user's interface was developed. We need to update it a bit for the specific users. Also, there is an opportunity for virtual tests to be done that can have an impact on the technological processes. Now it is needed to develop the virtual sensors to show so the density of pulp, so to develop the dashboard to visualize the process for all the users, and to calibrate the model using the historical data in order to achieve the determination coefficient up to 75. So what is needed? That's it. Thank you very much. Thank you. I have a question. Whether the model provides certain data. Did you compare? Did you compare the operators? How they are making the decision, how the model is making the decisions. We haven't achieved the determination coefficient yet when AI is maximum close to the real conditions. It's too early to say now, and data scientists, you are hiring them, developing. The model is developed so in-house, or you hired someone. We are working with the hired company. Okay, thank you very much. Thank you for your presentation. Thank you. The next speaker, let me introduce him, Johnny Witter.
Tell us about building a roadmap to a world-class digital mine.
Cool. Good morning, everyone. Welcome and thanks for coming. My name is Johnny Witter. I work for a company called MTS, and we specialize in helping mines make the most of their digital and mining technology. So today, I'm quickly going to talk to you about how to build a roadmap for your digital mine. It's quite a relevant topic today, and we're talking about the steps you need to go through in order to hopefully have a successful digital transformation. So, a quick overview. So we'll cover what is a technology roadmap and why is it important? Where are you on a technology roadmap? And what are the steps for yourself and for your mind to get to a world-class digital mine? So, step one. So what is a technology roadmap and why is it important? So each digital transformation is unique. So each mine it's at a different level of technical maturity. It might have a different mine life. It might have different infrastructure, different local regulations, and different budget requirements. Therefore, each roadmap needs to be unique and specific for that operation. And also, digital transformation is challenging. There's many cases where digital transformation hasn't worked. It could be that the installation was not correct, there was poor data quality, or there was failed stakeholder engagement. So it's important that you have the correct steps in place to be successful in your technology transformation. And in the bottom there, that diagram basically goes over that each mine will have a different roadmap. So not all mines have the same goal. You might be looking to achieve different things. So it's important that you have a unique route to get to your digital transformation. So just a quick example of a classic steps you would take for a digital transformation. So in this example, we're looking at becoming a world-class mine in terms of your load and haul operations. So in terms of technology, step one, you'd work with digital production tracking. So that would be taking your reporting of tons and cycle times and overall material movements from recording on paper and pencil to recording it digitally. So that might be through manual input into a system, or it might be through some automated tracking. And so the benefits you get from that would be you'll get more accurate reporting of tons, and you get more efficient way of recording those data. So that's step one. And then step two, you would probably start to implement a basic fleet management system. So that's when all the trucks are controlled from a centralized location, instead of one person in the pit on a radio controlling where the different trucks go. There's someone in the control room that's got a more holistic view of the whole operation, and they can tell you exactly where the trucks need to go to reduce hang time and to reduce queue time. And so with that, you'll probably get increases in production, reduced hang time, and more accurate cycle times, which will be used for your planning of your operations. And so we quite often see, in terms of figures, we quite often see 20 to 30% improvement in productivity from operations going from step one to step two here. This is like a really key step. It might not be that technology advanced, but in terms of return on investment, you're getting a lot of value for your money just from going from step one to step two. And the third step could be having a more advanced fleet management system. So that's when you're going to be using algorithms to do lots of complicated calculations to work out exactly where each truck will go based on certain conditions. So we're going to be looking at travel times, dig rates of the equipment, and it's going to be doing lots of complicated calculations which humans won't be able to do to find out the most optimum routes in that truck. And so there you're going to be gaining lots of increases in productivity again, and probably reduces in idle time. And then the final step, when you become a world-class operation in terms of load and haul operations, is when you become an autonomous haulage system. So that's when you've got your driverless trucks, they're operating without any operators, and you're seeing increases in productivity, safety gains, and various production improvements, and potentially reduction in operating times. Reduction in operating costs, because you're not having to pay for those labor wages. But it's important to think about the different complications as you move up the pyramid. For example, difficulty. As you move up the pyramid, things are going to get more difficult. Cost is going to increase as well. So it's going to get more difficult, it's going to increase in cost. And then an important factor here is return on investment. So it's an important factor here to consider return on investment. You need to be considering return on investment at each stage of the process. And here, return on investment is hard to determine. You quite often will get a lot of return on investment from just doing the basic things right. So like I said earlier, going from step one to step two, you could get a really large return on investment. And also because the costs are a lot lower at the bottom of the pyramid, that's going to make those calculations more beneficial. So it's something to consider as you move along your digital transformation. Obviously, return on investment is what everyone's looking for. If it's not going to be beneficial to get to the very top, you need to be thinking, well, what's going to be right for my own operation? So that's something to consider as we go along. So then, before you start your digital transformation, a few key things to consider. So define what your end goal is. You need to have a clear end goal in mind, and you need to determine what success looks like. And then, do your goals align with your operational business goals? So is this just a nice to have that you thought we need, or is it going to help solve some of your business challenges? So that's something to consider as well. Is your solution future-proof? So obviously technology advances at a very fast rate, so you need to be thinking, is this thing I'm installing and I'm spending all this money on, is it going to be future-proof, or am I going to have to rip it out in 5 years' time, and it's going to cost me a lot of money for not a lot of gain? And so obviously when you do your return on investment calculations, that's something you need to consider as well. What is your budget? As we discussed earlier, budgets vary significantly depending on where you are on your digital transformation. So it's important to consider what your budget is in terms of both CapEx and OpEx, because as we've seen, OpEx can change depending on where you are at that stage of digital transformation. And then what is your existing systems to have, what existing systems do you have to integrate? So this is an important one, sometimes gets forgotten. So what existing digital solutions do you already have in place? Quite often we see lots of mines where we go to and they might have a truck with 5 different systems installed, and each system's got its own box and it needs its own maintenance. And so you basically paid for the same thing 5 times, and you have to pay for maintenance of those 5 different systems. So it's important to think about how this system will integrate with my existing systems. If you only have to pay for one solution that covers your whole operation, that's going to cut costs and make things more efficient. And the final point there is, do you have the right team in place for the project to succeed? As we've mentioned earlier this morning, technology isn't just about technology, it's also about people. So you need to have a look and see, have I got the right people in place? Just because I'm good at IT doesn't mean I'm good at digital transformation. Just because I'm good at mining engineering doesn't mean I'm good at digital transformation. So it's important you have the right team in place. This could maybe involve bringing in external parties as well, because this is a key area where we see digital transformations failing, is there's just not that knowledge on site to help this succeed. So those are a few things to think about before you start. And then step 1 in your digital transformation roadmap will be discovery. So here you're going to be analyzing your current systems in place, what processes, what people, you're going to be doing your stopgap analysis, and seeing if you can identify any key bottlenecks. And then you're going to see, based on that, you're going to rank all the complexity of all the different digitalization projects. So this is an important step. We would suggest you don't start with the most complex thing first. Start with something simple and easy to go, and then that should help things succeed. And then you've got to plan your timelines, budgets, engage stakeholders, etc. So that's step 1. And then step 2 is strong foundations. So you're going to focus on a proof of concept. You're going to concentrate on data quality and consistency, and embedding those key behaviors, as we said, about people, not just technology. Getting the basics right first, and starting with something simple. And then step 3, you're going to define a stable state. So here you're going to benchmark your operation. You're going to see where you are at the moment and where you should be in the future. Evaluate and adjust systems and processes as you go, and you start to implement successful change management. And then step 4, expand and diversify. So once you've got basics right on that key proof of concept, you're going to start to expand to the remaining systems and processes. And you're going to start to use data as well to start to monitor that, comparing that to your benchmark that we discussed previously to make sure things are going right and to plan. And then finally, stage 5, you're going to hit your business goals and hit your full potential. So here you're going to streamline the process further, drive innovation across the whole operation, and you've got a cultural change here, and you've achieved, and it's achievable and it's more sustainable, so it's not going to fail. So that's the 5 kind of key steps. And then kind of 4 key takeaways. So point 1, don't get distracted by shiny objects. So there's lots of great technology out there. There's been lots of great talks about various new technologies, AI, digital twins, IoT devices, etc. However, you need to be thinking, are these going to be right for my operation? Are these on the critical path? Are these going to solve the problems I have for my individual operation? So it's important you don't get distracted by what looks cool and what looks fancy, and think about what's going to work for your individual operation. And step 2, it's important to walk before you can run. So plan clear, achievable steps. Don't try and run towards the end solution. Set realistic timelines and avoid running towards the end goal. It's important today that world-class operations get the basics right as well. So they're world-class with the basics, not just sort of really high-end stuff. And then step 3, avoid siloed projects. So that means avoid individual projects competing for resources. As we said before, infrastructure, if there's various projects competing for the same amount of infrastructure, it's going to create conflicting goals potentially, and you can have suboptimal infrastructure. And then the final point there is whole company buy-in. So we said again, people, you need whole company buy-in, all the way from the CFO to at the top to individual operators. So people are key to digital transformations. It's crucial that every stakeholder is engaged and understands the end goal. And any failed change management is a common issue because of the people involved. So that's it. Does anyone have any questions?
Thank you. Коллеги, вопросы к докладчику есть какие-то?
Do you have any questions to the reporter? Okay, thank you very much. Colleagues, I'm going to present decisions of 1S for digitalisation, automation of accounting and planning using 1C, and couple words about 1C company and senior company dealing with automation in mining sector in Kazakhstan. 1C company is quite seriously represented in Kazakhstan. In principle, in CIS, there are a lot of users of 1C, about 4 million, a lot of companies, and all the solutions of 1C have been localized for Kazakhstan. Actually, they cover the entire infrastructure of products in 1C in Kazakhstan available, and the company has developed infrastructure, a lot of partners all over bigger cities in Kazakhstan, and they can provide you assistance in the implementation and automation on the basis of 1C solutions. As for the line of solutions of 1C for mining sector, Synergy company I'm representing has developed a line of solutions which is represented as a solution ERP or standalone solution for operational accounting in the mining sector, and we'll discuss it a little bit later. And also we have solutions for automations and management of repairs and maintenance, which are actively implemented in Kazakhstan. There are solutions for accounting and wages accounting, for financing and budgeting management, for master data management, integration, document flow, industrial safety management, and so on. There are lots of uses of the line of 1C mining sector, in particular in Russia and in Kazakhstan, and we are actively involved in Karajara project, and I hope that in the nearest future we will launch it into operation. So as for the functioning of our solution of 1C mining sector, the key objective and the key paradigm of this solution. Actually, we are collecting all the data on the mining sector, from geology to mining to processing to loading in the same value chain, and that allow us to compare the data and get the throughput process that would allow us to control all of these units at the same time, including geologists, including mining, including transport staff, processes, technologies, so on, technical control services, laboratories, and so on and so forth. So there are 3 main levels, including geological works, management of processing, management of shipments.
The main trend of all our last projects, it's integration. Integration with different solutions exist and systems exist in different processes. For example, in Magazine mining project, this is our leading project. We integrated with microban biobank, with dispatching system, with weighing systems, with SCADA system in the plant, LEAP system integration, and weighing for the movement of the products, fueling systems, so integrated it with the systems for staff management. And if we are talking about transportation, then we integrated our system with system for transport and weighing systems. Also, there is a function that can be used to manage the equipment, to manage staff, and because this data can be used for salary estimations and so on and so forth. ERP in our system, we are paying to planning. We are working on the automation of the production program. We have financial plans. We have production plans. We have exploration plans, processing plans, loading plans, and shipment plans. So plans for repair of the equipment and talking about exploration management, we have the function how to record reserves. We are not replacing any systems. We are integrating with them, and we are using this data from other systems to build the planning system. Another function that we have, this is so the norms and standards for activities and shipments, so calendar planning, shift planning, operational chart, operational recording of the indicators, and these are all the functions that we have in our system. Macromine GeoBank in Magazine company, we are uploading the structure of the deposit, then the next service is planning, and then we can get so the concentration of the block, and then we get the information about so the shipment of the ore, and then we got the information about the residuals of the ore by blocks and by horizons. Automated recording of the ore and integration with automatic weighing. When the ore comes to the storage, we understand immediately from which excavator this ore is coming from. Then we got the data from the GeoBank, and we know the information about the concentration of the ore, and it means that we get this information about the content and the concentration of the ore that we have at our storage facility. Okay, management of the processing of the product. Here we are preparing the ore for processing. What we are doing here, we are planning the calendars, we are planning the shifts, we are recording the processing, so unfinished production, technological indicators, so adjustment of the processing of the projects, analysis of the processed products. It means that we are automatically uploading to this recording system. So in all our latest projects, we try to minimize human factor, meaning that we try to exclude human from entering the information into the systems, because it means errors, and mostly in our ASP, in our system, we are using the data from other systems, so avoiding these human errors. here, this is the top desk. So the recording of the process and integration with SCADA. This is, you see how it is done, how it is integrate. Other data from other systems are used in these recordings. So from the production lines, the information production lines, idle time at the plant, enrichment plant, we digitalized the whole plant, all the nodes, all the technological processes, and using the technical flow chart, we are monitoring, control the processing at the plant. Also, we are recording unfinished production, calculating different dynamics. What is the important module or block in our system is the quality, product quality management. So we are comparing this with other deposits, and then we can record the batches, and then we can build the balance of the metals. This is the function. This is a metal balance template, and with this function, we can get all the operational and regulated balance. The system is very useful and convenient to use. Colleagues from Polymetal also value it high, and so it helps to use different data source for the metal balance of metals. Of course, we cannot avoid equipment management, because all the mining works are done by the equipment, with the equipment. So that's why we need to plan the availability of the equipment, regulated idle times, and then we use all this data so to calculate and estimate the fuel needed for all this equipment. It means that we can manage and control the utilization of the fuel. So we know how much fuel we have at our storage, how much should be used for the shift, and then we can analyze the fuel consumption by activities in the plant. On the slide, you can see the top desktop of the dispatcher. All the data are received by the dispatcher automatically. And then the dispatcher gets automatically the data about the driver when he gets his order so all the census data. So from the petrol stations, the dispatcher gets the information about the fuel consumption and so on and so forth. So the dispatcher just checks this data, and if the and also, for example, if the dispatching systems are very cheap, then the dispatcher cannot control the idle time. But in good systems, so the dispatcher can monitor also the idle time of the equipment and the vehicles. Shipment management. It can be a separate report. Actually, this management system is very complicated. The whole presentation can be devoted to that. But we are monitoring all the shipments, even the shipments that are shipped abroad. And it requires great work to be implemented. For example, at Ural Best, we have been working for more than 2 years, and half of this project was devoted just for shipment, because this is a great block of work that should be done. Also, staffing and salary management and recording. So especially if you're talking about different salary rates and different bonuses systems used for different staff. That's why we are collecting all this information about the staff. Then in this module, you can calculate the working time and estimate the salary and bonuses. That's it about my report. If there are any questions, I can answer them later. But now I'm giving the floor to the next speaker. The next speaker is Nikolai Kasuhin, head of the Direction Mining Solutions Department, the Rexsoft company. Nikolai will talk about automation and digitalization in the mining industry. Hello, colleagues. We are glad to welcome all of you at this event. It's not a secret that digitalization today is of global nature. It is specific for any sectors, and mining sector is not an exception from that. The mining sector is also going through digitalization, but unfortunately, the mining sector is not the leader in digitalization. But still, some of the mining companies have shifted already to the implementation stage of digital solutions. Some of them you can see on the slide. The focus of all these activities is to improve the performance of the processes. The sector is ready to transform. Based on the assessment of the World Economic Forum, so digital transformation could bring about $320 billion from 2016 to 2025. It's quite a great impetus to implement digital transformation, but still the sector is facing certain challenges in digital transformation. These are all problems known to us. Now, when we have such a variable as digital transformation, some of these problems can be resolved or minimized. One of the companies, Salesforce, they conducted a survey. They asked how important is digital technologies in your company, in your organization. About 700 organizations participated in the survey, and the results of the survey are quite interesting. We can make the conclusion that the companies recognize that digital technologies are the driver of their progresses. But despite of the availability of many digital technologies, actually the potential of these technologies are not implemented, are not fulfilled completely. That's why the question is how we can assess the value of digital transformation, how to assess the risks of the implementation of digital transformation. We understand all these risks. The main risks of digital transformation you can see on the slide. The main risk is a lack of understanding of the expected outcome. The company surveyed 700 companies, and 70% of the respondents could not formulate exactly what are their expectations from digital transformation and what do they mean by that. Another risk is independent attempts to develop the roadmap for digital transformation in-house, because the users they try to install a lot of technologies, not understanding how they will be interlinked with each other. Also, qualification challenge, so competence challenge, then in-house developments, and then these developments cannot be scaled up, and when the developer leaves the company, then no one knows what to do that. Lack of scale-up plan and the lack of clear business justification. We believe that it's better to develop a very clear digital strategy and the roadmap to support its implementation, which is based on the interlinkage of the business processes, company infrastructure, and the competences of your staff in your company. For that, in our company Rexsoft, we are in favor of the approaches like that. We call it digital navigator. When you use the comprehensive approach, starting from the strategy and vision, ending up with the implementation of digital products. We, as the consulting company, we are ready to be engaged in the development, defining the milestones for the development of your company, comparing this information with our knowledge database. We are ready to help you to assess potential impacts for our clients, and we are ready to help you to develop the roadmap for your digital transformation, justifying every step, every activity. As a result of that, our clients are getting the specific list of activities with the specific duration, how and where they should move forward. On this slide, you can see the standard process of the mining company. Even now, we have certain developments already, almost for every stage of the processing. The Rexsoft company, as the developer, we are developing products for mining companies and mining processes. We are developing dispatching systems. We are developing systems based on the machine vision. So we are covering processes for excavation, transportation, enrichment. And here, what you can tell, our company, it's not just consulting company. We are ready to select for you technical solutions and equipment among our partners, or we can propose you ready technical solutions, and we are ready to help you to implement those solutions based on the roadmaps that we helped you to develop to support the implementation of your digital strategy.
As an example, we had a request for selection and assessment of technologies of repairs for mining transportation complex for maintenance and repairs and midterm prospects. We made an analysis and we checked what are the technologies which are applicable and available in the Russian market. We assess these technologies with the prospect of the compliance with the proposed horizon of implementation, where 1 is close horizon and 11 is far horizon. Implementation of printers or robotization. So we checked it for particular client, for how many business processes every initiative may impact, every technological solution. And we made a conclusion that in the horizon of 3 years, the biggest impact on business processes can be expected from automation of providing permits or using mobile servicing. And here we used analysis and control of task. And also, we proposed the client to be focused on these processes. We proposed the client to develop own permitting system, and I'll not describe it because you are aware of that, what are the business effects it may deal. And as a result of the number of permits and the time preparation of staff to work significantly decreased. For instance, 21,000 permits to work have been provided, and since this figure decreased by 10 times, and paper documentation was decreased, and the time for preparation of the staff was also decreased. That resulted in the economic effect, and we understand that often we have a situation when consultant recommend implementation of particular solutions, then they leave, and we got in a situation when the solution was implemented but no effect was gained of that. Why? Because the business processes have not been reformulated, and we propose to do regular audit of existence of business process to identify the areas for the possible improvements. That is why we develop metrics for control of operational efficiency of processes, difficulty, average time of a process, or a number of approvals. We discuss these metrics with each client and get coordination, and we recommend to make this assessment once or twice a year. It's not important for us what are the technologies that we plan to be implemented. It could be dispatching system or high precision positioning or quality assessment. For us, the most important thing is to focus on the approach that one should not strive to sell a client a particular digital solution. We have to provide also consultancy support based on knowledge base available with us. We should help the client to adjust business processes and create mutual connection. We are prepared for cooperation with you, and you are invited for cooperation. And we will be happy to have this partnership, and that's all with me. Thank you. Colleagues, I'm sorry. Just a second. Just a brief comment. If you don't mind, on Tuesday, we are going to hold a webinar on digital transformation, and we would like all the participants of this forum to come to this webinar where we will be discuss in more detail of what we are doing. We'll respond to possible questions on the website. This is a QR code that you can use, and our marketing department will circulate this information. So if you are interested, please switch on. We will be happy. Thank you, Nikolai. And the most difficult thing is to calculate an economic effect of digital transformation, and that differs us from other consultants. So we are prepared to see how at every particular enterprise economic effect is calculated, and I'm a person from the sector, and I know that it should be proved. As a representative of subsoil user, we have to do that, and we are prepared to do that with our team of specialists. As IT specialists are not always capable to do that. And now, colleagues, the next presentation. Let us welcome the next presenter, Dmitry Shnadi, senior partner of Belkai company. He will be talking about intellectual system of automated management of technological process of concentrators. Good morning, distinguished colleagues. In my presentation, I would like to tell about the company I work, about the solutions we propose, and the experience of implementation of these solutions. We are dealing with intellectual automation, and we started in 2017 at concentrating factories. It is our key core activities, and also we deal with the projects in non-ferrous metallurgy, and I would like to say that our specialists have significant experience of working with industry and energy in ferrous metallurgy. And since 2017, we have been focusing on concentrates in mills, and during these years we managed to implement the whole list of successful projects with the biggest mining and metallurgy companies. The outcomes were marked with competitions with Null, Nickel, MGD, and we became the winners of many competitions. And we are in a very close cooperation with scientific organizations in the sphere of automation, in the sphere of technologies. And this year we have started our rep office in the Republic of Kazakhstan. Actually, what is our product? In short, it is a model digital platform, and you see a general structure of it on your screen, which is integrated in IT landscape of a company and receives the data from all existing systems, levels them and processes data, and then using different models, AI creates optimal management for a particular criteria. It could be improvement of recovery, it could be the growth of productivity with ensuring appropriate quality or composition of the two criteria. The result of this optimization is transferred directly to existing or implemented by us SCADA systems as installation in a targeted conditions. The system operates absolutely automatically under the operator's control. From functional point of view, the system is also modular. It comprises of several functional blocks. They are shown in a schematic way on the slide. We started working with the data. These are the models of data quality control, data enrichment, and a separate block is a virtual analyzer, additional system of obtaining the data from Internet of Things, and applications there where it is needed. Another step is technology control. The technological advisor allows you to control, on one hand, current execution of technological regimen at the company, and on the other hand, it is possible to construct dynamic adaptive requirement that can be adapted to properties of the ore structure of operating equipment. And also we have a product which is a digital twin, And particularly, it is a dynamic flow model of a factory. It allows us to get additional information at the points where we do not have the data, we do not have the sensors, and use it for management and control. And the most important part, the main key player of a system is an advisor system, which is then transferred to completely automated mode. And also we have a BI system, a BI module that allow us to assess the work of a system and involvement of teams, compare them, compare by teams, compare by period, compare by shifts, and perform different analytics. This is an example of implementation of a system at Gaiski GOG, one of the most recent. We started in January 22, and we got economic effect with a growth of extraction 1.36 of decimal points, and now we are covering a remaining part of the factory, and we plan that this work will be completed by the end of the year. We separately propose the product Belka Flow Vision, which is also implemented at Gaiski GOG. It is a system of machine vision for flotation that allows you with cameras to assess the regime of work of flotation. First of all, some critical situation when we have a leakage, when we have the speed of removing the foam, and some other characteristics you may see on the slides that characterize the flotation process and allow the system to be more efficient and to be operated in a more efficient way. The product is constructed and produced by our company. It is a system. It has a software and hardware complex that includes cameras, a lighting system, industrial computer. And now you see how it looks like in a real situation. Equipment installed on flotation machines, and the information is provided in the form of dashboards in a convenient format for operators and dispatchers. Another product, Belka New Life, is a system of control of regimes of work of mills. Now we applied it for ball mills, and now we also plan to have applied for rod mills, but now we are resolving the task to assess the load of both in online mode through the control of vibration of the drum of a mill. And the system is also equipped with additional sensors on reductors on that allows us to control the condition of equipment. And since information is collected in this several this process, the specific of the system is that we do not just transmit separate data, we provide this whole spectrum of signal. You see the example of spectrum map from drum of the mill. This is a huge amount of data, a huge amount of information which is further processed at server and provides an understanding on one hand what is the regime of the work of the mill from point of view of technology and lot of balls, and we can also focus different things like VNT footage that can be used for operation, and Belka Twin digital twin of concentrating factory. Here we have a dynamic model which is based on physical characteristics of the equipment of mill, hydrocyclone, a solar ejector, so on. This model works in real time. It receives the data from the sensors available at the concentrator that could be of the flow of ore to main mills, supply of water, density in certain points, the sensor that measures the final product. But in the course of the process, we do not have enough sensors, but this model allows us to replenish this information and use it further for management and use it further for optimization of technological process in general. Another area of our work is the area related to cluster analysis of parameters of ore. Here we resolve the task of projecting of the work of a concentrated mill, understanding on how mining plan will be developed. We resolve the task of optimizing the planning, and we project what could be the production and the plant, what could be the recovery rate, and everything depends upon the mine. And we resolve this task based on clustering. We use machine learning apparatus where we use all available data from existing systems like GMX and other systems, and we process this information and we create maps like you may see on the slide that would allow you to understand the ideas on how this particular type of ore cluster will be concentrated at the mill. That would allow you to make optimum planning and manage concentration process. I would like to say a couple words about success factors. Why we are successful? From our point of view, it is important to have 4 key elements. The first element is expertise. Expertise in AI and artificial intelligence, and expertise in information technologies in SCADA systems. Now, information security is very important. We're also working with it. And another part is technological expertise. In our staff, we have technologists with significant experience of practical work at factories that help us to develop the model, to develop the algorithms of management so as to make them livable and adaptive for working in real conditions when we have an issue with data or with technologies or with some changes that are happening all the time.
And another important block, this is the changes management block, because we believe that we can achieve success only if this impact from the changes is ongoing, continuous. So the success should not be just after the transformation, but what is important for us, it is important that the product should be utilized further. That's why it's necessary to look at the organizational chart, production team, engagement of people, all the people, operator, so developer, they should be part of the team developing this product, and together we and them, we have to tell together that we did it, and this belongs to us, and then it helps to manage more efficiently. But it means also that we have to pay attention to KPIs, organizational structure, and we are doing all that. So talking about the stages of the project, first of all, we start with diagnostics, then we have proof of concept stage, when we analyze the best practices, doing the economic analysis and evaluation, what we can achieve during as part of the implementation. Then we look at the equipment of the plant, so identifying benchmarks, helping us to understand whether the client is ready for this transformation, what kind of products or technologies we can implement now, and what can be done later. Then we implement the working model in real time that is given an effect already. So then when we use this product in the operational stage, then so we can go to the automatical mode of the working of this product. So here on the slide you can see 2 months for this transition period to automation mode, but in one of the companies we were able to do it in 2 weeks, almost after the trial period for operations. Then in 2 weeks we are able to put it into automated mode, and if the client is happy, then we can scale up for other plants. Thanks. You are running after time. Thank you. Thank you, Dmitry. Colleagues, the next speaker is Konstantin Kiselyov, the co-founder of Conundrum Industrial Company. He will be talking about revolutionizing process control, harnessing physics-informed machine learning models for enhanced profitability, robustness, and sustainability in the mining industry. Thank you. I'm glad to welcome all of you at our conference. What we are doing How we can change the slides? Okay, what we are doing in our company, we are providing our platform software for mining companies, allowing these companies to implement and operate so advanced solutions in management using AI. I believe that we all can hear about the recent outcomes of utilizing AI in our lives. So we can hear it, how AI is applied in everyday life. For example, OpenAI company, they presented different models, and there are other many solutions with AI that helps us to resolve our routine tasks. And I'm sure that in the nearest 5 years, so we will change the world completely. In parallel, we have another revolution. It's utilization of AI in controlling the dynamic system, and it is already changing our approaches to management processes, advanced management processes. I would like to share what kind of methods are there and what methods we are using. I will give you also several examples, and I will tell you how this is being used in practice already. A couple of words about our company. Our system have been implemented in 9 concentrated plants in the mining sector, bringing an economic effect, more than $130 million of profit for our clients, and about 10 million of set points every day. In our company, we have more than 90 professionals, and most of our offices are located in Europe. We are focusing on the concentrating plants, covering all the process of this plant, so grinding, flotation, hydrocyclones, and so on and so forth. And all our solutions can be joined into the plant-wide optimizer, optimizing all the processes, all the stages. The whole plant is being optimized for one goal that you have in your business. What are the challenges in advanced process control? First of all, we would like to have optimal control for it to be performing, effective. We want this control to be robust. For example, if you can see changes in the ore, it shouldn't have an impact on our management processes, control process, and also we have to pay attention that our management processes should not be line processes. Also, we want our control systems to be useful in changing dynamics, because sometimes some process changes the dynamics of the whole system, and we need to take that into account. Also, we want to have wide optimizations, plant-wide optimizations, because we want to optimize all the processes of the plant to achieve a unified goal. What are available in the market? There are linear models available. There are hybrid models available when linear models are combined with fuzzy logics plus machine learning estimators. And also there are adaptive models when you still have linear model, but you optimize it for changing conditions. But what is the problem of this approach? First of all, they can't capture non-linear dynamics of the processes, because our dynamics in the concentration plants, this dynamics is not linear. So that's why if you are using fixed models, if you know how control matrices are looking, big matrices, they are fixed ones, they are difficult to support, and when something is changing in the plant, you have to rearrange them, and it's difficult. That's why these fixed models works poorly, and it's difficult to use them for complex multi-stage production, to use it as a plant-wide optimization. What we are using and what is the trend at the market? So we are using physics-informed machine learning. Actually, we are merging machine learning with physics laws. Actually, what we are doing, we take into account the knowledge of the dynamics of our processes, and we incorporated in this knowledge on the dynamics of the process into machine learning. First of all, mass balance, some symmetry of our process that we know, the structure of the process, some dynamics that we know, and our limitations in our processes. We incorporate everything in machine learning. These are all. This is all known dynamics that we, and then not known dynamics we are restoring using machine learning. That systems they are learning faster. They are more stable, bringing more economic effect, and also they can be optimized for complex multi-study processes and for complex goals, business functions and business goals. Just one of the examples, one of the methods that we are using, this is the Koopman theory method. This is a new area in the machine learning. The Koopman theory itself is old, but it's being developed more because we have a lot of new mathematical knowledge. What we are doing, we are telling our system is not linear, and let's find such an operator that will bring this system to the space where our system is linear. It can be done using coders, and after coders, we code the dynamics of our system, because here you can see the differential equation of our system, of our production processes. And in order to make our system more robust, you can work in the linear space, not in the space. So you can work how it is done in quantum physics, actually. How it works. Examples. The first example, we can optimize flotation operation for nickel and copper. 4 sections of flotation, more than 60 floating machine, and the impact is more than 2.5% increase in recovery. This is the proved impact, and I can give you the references to look at that. And also we have the increase in quality, and the process is stabilized. This is a very simplified scheme of the process. This process will be staged 1 because we mean several operations: main flotation, recleaning, and we optimize every stage, every operation, and then this optimization is merged into the chart, which is synchronized to achieve with a single goal. The second example, optimization of AG mill control. Here we are talking about the plant for copper and iron. It means that they have 2 lines, production lines. This is the impact is increase in throughput is 2.9%. Also, secondary impact was that 2% reduced power consumption. The system is working stably in stable mode, and I can give you the reference. And another system, this is optimization of crushing circuit. It's a big plant producing platinum, and it's a big multi-staged operation circuit, and primary and secondary grinding and crushing, and the increase in average throughput is 2.6%, and also optimization is done in the real-time mode, and it's stable now. It's stabilization of all properties. Thank you, everyone. Hopefully it was interesting for you. Thank you, Konstantin. Very interesting presentation. And because of the time limits, no questions, sorry. And colleagues, the next speaker is Eska Takola.
Sandra minerals processing. Tell us about the real-time particle size monitoring from every cyclone, and for optimization of grinding and beneficiation for line net metal production.
Thank you, Mr. Chairman. Ladies and gentlemen, my topic is focusing on how to maximize the net metal production by improved grinding controls. So, the problem, everybody now that the metal prices are high, everybody wants to maximize the net metal production, but how to do it fast? Fast solution would be to grind coarser, but how to do that without risks in losing recovery in the further stages of the process? For that, we have developed at Sidra a specific particle size measurement system that enables direct controlled trade between the throughput and recovery in the process. Conventional solution has been to take samples from the consolidated cyclone battery overflow and then to have roping detectors there to detect malfunctions. Now we are measuring directly in real time from the overflow of every single hydrocyclone the particle size, and that enables us to optimize every cyclone in the battery to work better and then to prevent also roping before it happens. The measurement principle is simple, so it's a waveguide probe that is entered into the overflow pipe and the particles hit that waveguide probe. And the impact generates an acoustic signal that is calibrated into particle size. So we can follow up to 5 real-time direct particle size measurement limits every 4 seconds from every cyclone overflow. And that reduces the particle size variability. And it enables automated grinding controls, what we call macro controls, and it enables individual cyclone management and control, what we call micro control. Also, controlling the particle size over the operating range can prevent the roping events before they happen, and you can save also in grinding energy. Some customer statements. So based on this, we prevent roping before it happens and squeeze the particle size distribution to be sharper and optimal for your flotation process. We can also, it's good to know that the cyclones in a battery, they are not operating similarly and they are affecting each other's operations. So based on our measurements, you can select the best combinations of best performing cyclones to be in operation all the time, and also as important is to avoid the worst combinations of cyclones that are working together simultaneously. Here we see an event where one of the cyclones, the blue one there, has gone roping, and then it means that as most material go there, then the other cyclones are producing fine. So the red line there is showing the average, and you can see that there is no big effect on the average. Based on that, the normal controls would think that perhaps we are now having a little bit harder ore coming in, so they are reducing the throughput, which is a wrong decision for control. PST would have been preventing this roping event. So based on this, we can utilize the same kind of typical grinding controls there, but we can squeeze the particle size distribution and optimize it to be coarser, so increase throughput in that way. Okay. So what we call NMP, net metal production strategy, is that we are not optimizing the process by optimizing throughput and recovery independently. If you grind coarser, you are able to increase the throughput there, and at a certain point, your recovery starts to go down. So you are getting losses in recovery. But you can sacrifice some of the recovery for the throughput, so to generate the net metal production there. There we do have some immediate comments from customers already from the commissioning time, so we found out different kind of malfunctions in their processes. Perhaps the widest test was done by the biggest copper mine in USA. They run same line 6 months with PST control and without PST control in their copper production. And the result was that with PST control, they processed 10% more net metal out, which meant roughly $60 million per year on that production line. Simultaneously, they were saving roughly 1 kilowatt per ton on grinding energy, of course, because you are avoiding the underloading statuses in mills. And previously, they shut down flotation cells for maintenance every 6 months, roughly, and that was a 3-day shutdown in the process. No longer have to do so with PST. Minera Los Pelambres made this kind of program because their ore grades were falling down and they were losing net metal production because of that. And they selected the PST and NMP strategy as a base tool for this improvement process. The results were that there was a 6% increase in production in tonnages. They sacrificed 0.9% in recovery. So in net metal production, there was 5% increase. And they were able to improve the net metal production there. Another copper mine commissioning stage, we found out that 5 of the 17 cyclones were not operating properly, so we could immediately do improvements there in that process. This is a gold mine in South Americas. They had a program that led, based on PST, to 8% increase in throughput. A copper mine in Bulgaria announced in MINEX conference 2019 that they achieved 5% increase in production combined with 2% improvement in recovery with PST. So we have proven that the mill classification circuit is the process area where the greatest potential for net metal production improvements can be made with significant economic benefits. The primary benefits are that we are doing real-time direct particle size control. And we are having the microstrategy controlling the individual cyclones in a battery, and then the macro strategy controlling the total grind circuit. And we are then doing that maximized net metal production. It's up to the customer, of course, to select where is their optimal point. Do they want to go for maximal recovery or maximized net metal production? Secondary benefits are that you are preventing ropings, you are reducing grinding energy consumption, you are reducing water usage, and you will have new insight into the process, and you can reduce the variability in the process. And reduction of rocks and pebbles in flotation cells, so it means increased process uptime. And also improved safety, as you don't have to go to clean those flotation cells. Thank you for your attention. I'm sorry that our booth number is wrong there, so welcome to discuss more about this on our booth 35. Thank you.
Let's go, thank you. Коллеги, следующий докладчик.
The next presenter is Nikolai Polshin, expert in digital solutions of Metsaut Tech Company. He will be presenting about a technological digital twin for concentrating and metallurgy enterprises. MINEX concern. Distinguished participants of the forum, my presentation will be on such solution as GMINEX, which is a technological digital twin, and I hope that you are not sick and tired of listening on digital twins. And I would like to start with a statement that the industry where we are working, as well as other industries, have been always focused on improvement of the efficiency. And asking this question, the most often response is digitalization, but still it is not very clear how and what should be done, what activities we have to carry out to understand and reach the objective on improvement of efficiency. Many producers, coming from the experience and from the activities, establish solutions which they believe to be correct. Our company significant experience from the point of view of development technology, supply of equipment, calculation of equipment for concentrating for metallurgy processing, and we produce a whole spectrum of automation products. And we also have our own vision in which direction digital solutions have to develop, and the response to it is a project as GMINEX. So as to understand what is GMINEX, we have to understand where it is based in the hierarchy of automation systems. In the lowest part, we have technological processes and the key technological equipment. The second level is control devices, some closures, analyzers, and so hands and off production. The next two levels are responsible for automation. The base automation is SCADA solutions, which is based on different field decorators and some basic contours of control. And the next level is a system of improved control of technical processes. In English, what we call MPC, but it is a more comprehensive system that are focused on stabilization of the processes and its optimization, not within the framework of a particular equipment, but at the processing level. And at the highest part, at the highest levels, you see the system which are focused on optimization of the entire manufacturing in mid-term and long-term processes, and economic optimizers when we assess production, not from the point of view what is the production rate and what is the output, but how much it costs to produce these products. And if we're talking about GMINEX, and GMINEX is at the highest level, it takes the two highest levels, and typically it has an opportunity to move to the lower level, to SCADA level, and provide significant measures to stabilize increased contours of control, combining the whole automation of the whole enterprise into a single system. Where the process starts? Actually, there is certain base data on information on characteristic of raw materials on the process, and we have an understanding how much it costs to produce a product, some costs related to electricity on reagents and so on and so forth. And we have also product manufacturing itself, but to create a digital twin is the most important method for us, and we call it a black box. When we take the significant pool of information, trying to load it down into certain systems of machine learning, artificial intelligence, and then after studying all this data, some system is created that should predict in which direction the process should move and how we control the process. Actually, it tries to understand what are the correlation between input and output data, and using it create some technical solution. But we have very significant experience in such digital twin, and we can state that it is a good solution, especially if we are talking about single equipment or single process. This approach is working and it is good, but when we discuss the scale for entire complex of processes, when we have a lot of circulations which are not measured, automation systems will never reach the level when we be capable to measure every flaw in every characteristics. Our approach is that we establish a model of a process on the basis of mathematical models that in the scientific community are the models that describe the process that are happening in a particular operation. Could be a crushing, grinding, and flotation, or preparatory processes. And so based on this model that can operate in dynamic mode, we create this body of digital twin MINEX. And then we do integration with real data from production and third-party databases like information on geological properties of the ore that will be introduced into processing, and on production cost of the product, how much the elements cost, how much electricity we have spent. And then we have a process of learning. We use machine learning methodologies when we have real models so as to calibrate the factors and the ratios of the model of every process and get input data.
And to get the real output data from the digital twin, identical to the real production. And when we have the high level of synchronization, then there is an opportunity to optimize the whole production, starting from the help to the operator, how they should manage each stage of the processing, and ending with the top management of the plant, planning the production for decades ahead. I talked a bit about modeling and based on what we are developing our models. We are using HSC chemistry. It's a great platform for technological calculations. So it's a package of programs from 24 modules, and this product is available not only for us but also for our customers. The main module, it's HSC SIM. In this module, we are selecting the model and conducting simulation with all the functions to interpret the results of the testing or simulations to get the model itself, calibration model for the model. So all the processes are covered, starting from the preparation of ore, so up to the metallurgical processes. From the point of view of our company, we use HSC SIM to develop all the projects, whether we are talking about green plants, new plants, or when we are working on modernization projects, we use this modeling to assess the economic impact of implementation new technologies. When we are based on modeling and simulations, we can see the following roadmap, let's say, how we can develop digital twin, starting from the initial works when we have the deposit and we understand that it is reasonable to exploit, to understand the technology for processing, and And here, the implementation of the simulation is helpful because we can play and find technological scheme for this deposit to find the optimum for the production and configuration of the technological scheme. When we understand if the project is technologically, economically viable, then we can have the final optimization of the process, so we can provide the design criteria that will be used for the design of the plant and equipment, and then we can start thinking about the philosophy of automation. During the first two stages, more statistic models are used, but dynamic models are also used, are also provided by the program. And when we are thinking about the philosophy of the production, then we start using dynamic model to understand whether this philosophy is relevant or not, and then we can adjust something before the commencement. When we are at the commencement stage, the digital twin is ready for operation, meaning that we have some technical stuff, so there are theoretical data, but not practical data available, and this digital twin provides an opportunity for the operators to help them to manage the technological processes. And then when the plant or the equipment is launched, then the digital twin can be used for forecasting in real time. Thank you. That's it. If there are any other questions, please come up to our stand booth. Thank you, Nikolai. Dear colleagues, with that, our session is over. Actually, it's clear. The trend is clear. Digitalization is progressing. Those technologies are in demand, and you can see this trend as a joke. There is another trend. All our speakers, they are not wearing ties. This is the indicator as well. Colleagues, thank you very much. All the speakers, all the presentations will be posted on the website of MINEX. You will be able to see all the presentation in details on the 5th of May. Thank you.